So we're going to talk about AI tuning Linux. So let's welcome.
Hello. I'm Shung-Hsi and I work at Shung-Hsi, which is we're a company making Linux distribution, kind of like Ubuntu, Canonical, or Red Hat. And I want to have a quick introduction for one of the projects that I'm working on right now. It's called Phoebe, and what we're trying is to use AI on Linux itself and see if there is something that we can some benefit to it. And if you're interested, you can reach me at my Twitter handle or the email. Both are fine. So the problem right now, one of the problems, there's many, but one of the problem with performance tuning with Linux is that there's a lot of parameters to choose from, and also each of the parameters, they have some hidden meaning behind it. If you don't look inside the source code, it's really hard to know what kind of performance change you can expect from this parameter. Sometimes if you tune it higher, it might be better for your system, but for others, it might be worse. And also, generally speaking, when you do performance tuning, you're expecting the environment to stay constant. If it's not, it's pretty much impossible to tune. And after you tune it, they may leave the same setting for maybe 1, 2, 3, 4 years. They will leave it for a long time. And during that time, the environment may change, hardware change, everything changes. And it kind of, the performance benefit kind of get lost. And so the last thing about the problem is that since Linux has so much parameters, but I just make it easier with that. So when I say Linux has a lot of parameters, I mean there's a lot of knobs you can tune. So for example, if you go to top, sysnet, and say IPv4, these are all individual knobs that you can tune. So for example, here I have my TCP. So this is a setting that I have set for my computer for regarding the TCP memory on the writer side. And you can see there's like a bunch of numbers here. And if I want to know what it does, I have to do some research, look at this and say TCP, WLAN, and try to make a sense of it. So it's a factor of 3 integers min, default, max, blah, 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 blah. So you can see it's very, very easy. You can get out of hand. And when you're doing performance tuning, most of the time, you're just tuning one of them and see if it changes. And if it doesn't, you try the next one and so on and so forth. It's really quite a hassle. So what we're trying to do So what we're trying to do is try to see if there is some way to better tune the system with AI is everything right now. So we're trying to do it with AI. And first we're focused on the network part because it seems that network is what I know and what my colleagues who also working on this project knows. And besides auto tuning, one of the other thing we want to achieve is also self-healing. So hopefully it can prevent someone from being awake during their sleep to reboot the server or something like that. And there are also, so before we get into this, we also did some research on previous work. If you're familiar with performance tuning with Linux, TuneD, the TuneD daemon, I guess, is I think the de facto standard for performance tuning on Linux. And what it does is it has certain profiles that you can choose from. For example, there's the network throughput or the network latency or system throughput. So you basically choose on one of these profiles and TuneD will set all these parameters to some predetermined setting. And once it's set, it doesn't change it. It doesn't look at the system and update it. It doesn't just use some constant value. And here's also two works that I've seen that also try to do similar things. One is they use a genetic algorithm to see if they can mix and match some system CPO parameter setting to achieve better performance. And there's also another one that you support vector machines. And what we're trying to do differently is that we want to make the decision based on more system metrics. So those previous work, they basically look at the system using a single number. They will either look at the throughput or the latency. But Linux actually exposes a lot of more information. You can look at a single TCP connection, and Linux can tell you what's the round trip time, how many retransmission it's doing, what's the buffer window size, all these various matrices that we think will be helpful. And also, we want it to be running constantly to adapt to the latest changes. And also, instead of some hard constants, we want it to fine-tune those numbers to see if we can the best result. And right now, it's still in the pre-alpha phase. What I mean is that it doesn't work. Yeah, if it's working out, I won't be speaking here. So anyway, right now, at least we can collect the network metrics, and that's something that I've been working on for actually the past 2 or 3 months. And right now, there's 4 people working on it, all from SUSE. So if this sounds like marginally interesting to you, like if you have a lot of servers that do networking, like come talk to me or message me, I'll be happy to talk to you. And here's some links. This is the QR code to the GitHub link, and it's right now at SUSE it's something we call Hack Week. So during this week, I can ignore all my normal duty. I can just do this. Even if my customer complain, I can just like fly away. And I think this also DB is going to be part of the Google Summer Code project. I'm not really sure about this part, but it seems that they have submitted OpenSUSE along with DB or something. So maybe if that's something that interests you, we can. Like if you're a student, I believe it might benefit you. So that's it. Thank you, and if you have any questions.
So, are you looking at tuning individual machines like isolated, or all of like a set of machines all at once,
I think
like within the same network?
the final goal will be. I think the final goal will be tuning for a set of machines, but right now we're trying to just try to just tune one machine really well, and that's our short-term goal. And my colleague actually tried this today, and it turns out DB make the performance worse. So, but at least there's some changes. So we're working on that.
Yes. Can you share what kind of model you're applying to use?
So the model part, it's actually just linear regression right now, and I'm hoping that we could get some kind of maybe reinforcement learning model going, because the performance tuning problem is kind of different from something like image recognition, where you can see a bigger cat and you know it's cat, but for the network for the performance tuning problem, you cannot see a set of metrics and say, oh, I know I can change this and this and this to 5, 10, and 7, and magically everything will be in the best condition. So it seems like it's more of a trial and error, which is actually what the humans do. So yeah, my hope is we get a reinforcement learning model.
Yeah, it sounds similar to like trajectory optimization kind of, but maybe with more information.
Okay. I actually don't know much about reinforcement. Do you happen to work on
I'll talk to you after this.
Okay.
But I have one more question. So, would you like upstream it to the Linux kernel?
I think not in the short term because the Linux kernel is quite firm. I'm not sure what the word to it, but they're quite selective in what kind of code they let into the Linux kernel. And I think the AI being something that uses a binary blob model is a bit hard for them to accept.
Yeah. Curious, but if someone else uploaded like models with weights, even if they're not binary, but open source, it's checking a bunch of numbers and they're different.
Well, there actually is something similar. It's the firmwares used by Linux. A lot of them are just binary blob, and I think what Linux does is they store it in another different Git repo that's separate from the main source tree.
But we want to-
Oh, yeah. Yeah.